Alright guys, Chris here with Armattan Quads. It's been a very long time since I've made a video like this. Yeah, don't expect this to be entertaining, just more informative. I want to talk to you about some of the things we've been working on. Like I said, it's been such a long time now. Yeah, on that note, the last couple of years have been a bit different. A bit challenging for some people. I hope everyone is well out there. I hope you guys are all doing great. But yeah, I wanted to show you a few things today now. The reason why I'm showing you the Marmot first is because I actually want to talk about this a little bit before I show you our next release coming up very soon here, called the Armattan Beaver. So yeah, basically what you got here is the Marmot. We designed this 3 years ago, actually more than 3 years ago, but it was released, yeah, maybe, trying to remember that. Yeah, it's more than three. Would have been 3 years sometimes around March, I think. It's been over 3 years now since this model has been put on the market. Man, a lot has changed since then. In fact, I would say that right around the release of this model, or shortly before it, people started to pay attention more. Not pay attention more, but the general usage of black bucks became more understood, more used, more commonly used, and that's when, I think for a lot of different frames, a new design goal sort of came into play. So, for example, when we designed this, we had strength in mind. We wanted to have proper provisions for, just like any frames before, starting back in the K2 days and multi-Wii, all the way to 3 years ago. The frame has to fit the current electronics that are being used at the time. And of course, we always put a big emphasis on weight. We don't want something that's too heavy. We want something that looks nice. And of course, yeah, of course, as always, strength was always at the core of what we're trying to do, because these frames are a lifetime warranty. And obviously, one of the new core goals that we have when we put a design together is to make sure there's not too much vibration leading to the flight controller. Yeah, so I think that without further ado, I'm going to go ahead and show you the Armattan Beaver, show you what we've been working on. And here it is, folks. This is the brand new Armattan Beaver. Now this frame it's actually a bit crazy that it's been 3 years since we released a new flagship. I think COVID played a part to it. Of course, I was reluctant to do too much development at the beginning, but nonetheless, we spent more time tweaking things on this and trying different things. That there's essentially no frame in the history of Armattan that has been through so many revisions and tests and more revisions and tweaking. Nothing like this. A lot went into this part here, which is a very important part of this design, something that I talked earlier about having proper provisions. This has to do with this. Yeah, so what I'm going to do here is I'm going to go right ahead and go through the same goals that I talked about when we talked about the Marmot. I just talked about goals that we had with the Marmot, and I mentioned that we had a very important additional goal when we built this here, which was to reduce vibration getting to the flight controller. But I'm just going to go through our list of goals, I guess, starting with strength. I'm going to have to pause this now. My dog requires my attention. I'll be right back. Okay, so going with strength here, always been one of our core goals. With this, we got the thickest arms we've ever had on a 5-inch. They're thicker, and Obviously, some people complained in the past that a frame like this did not always have the weave cut in the right angle. But the problem with a frame like this is that it's a compressed X, so you're never going to get the perfect angle of cutting on a compressed X. If you wanted the perfect angle of cutting, you'd need a pure X main plate. All right, so that's one point I thought I should make. Whereas with the arms, you do not have to, basically you can cut them at the right angle, all of them, and they're add stiffness to them and it has strength to them. In terms of strength now, we've got our pretty much trademark tail posts here. This is going to be a molded rubber part. This is a TPU prototype here. This is going to be a molded rubber part for the antenna provisions at the rear. And then at the front we've got the cage, which this is something I really want to show here. Give me a second here. Okay, so if we go back all the way to the rooster, if you look at the size of the cage here, I'll put the rooster next to it. It's like the size difference is ridiculous. You put it as close as I can, right about there. Look at the size difference on this thing. This is an even much older model than the Marmot. This was back when the cameras were bigger. Obviously it's quite outdated. If we go only back to the Marmot, however, this is a Marmot cage here. We'll put that here, trying to line it up. About the same. You can see the difference in size is staggering. It's staggering how smaller this is now. And it offers really good protection for your camera. Let me show you the size, this side. I hope you can see. Maybe let me point the light better. Yeah, that's better. All right. This little guy here is what we call a cam saver. And what we did on this is we allowed for a lot of movement. The bolt is loose here now, right? You can see there's a lot of movement on this. And this is basically to protect your camera on impact. Obviously you got the metal cage. Tamya, be nice. I'm recording now. No noise, please. Thank you. My dog again. And what I recommend for this actually is that you don't need to tighten these bolts on here so tight, right? You need to tighten them just enough so that you're able to tilt your camera by forcing it lightly, right? But it's not completely locked in place. And essentially that's clear to understand. Once that's the case, if you hit an impact, a lot of the impact will be absorbed because the camera will simply move back, and by then hopefully the obstacle will hit the cage, not your camera. Right, so that's just one thing to note about this. Another thing about strength is the main plate here. It's 3mm now, and this is something that is not common on a frame design like this. Most companies go with 2.5, the popular companies anyway, for a center plate in order to meet weight, basically. Yeah, it's not easy to make a frame around 125 grams, 5-inch, excuse me, and meet like what I consider is sort of a don't go over weight limit kind of thing. But now we went all the way with 3mm for the main plate. Tamyam, give it up, please. Go play outside. Okay, sorry about this. Yeah, so we got thicker plate, thicker arms, and then on top of that we've got 3 different provisions for standoffs. So on that note, I need to talk about the provisions as well. Like I mentioned earlier, design goals are strength, good provisions, good weight, needs to look nice, and then of course, oh yeah, another one I didn't mention is ease of maintenance. Right, easy to use, easy to take apart, work on, that type of thing. Has always been a bit of a design goals as well. But yeah, we have 3 different position of standoffs here, and we've got 30-30, 20-20 at the front, 20-20 at the back, 20-20 at the front. And what we recommend on this, I'll show you. I'll show you in a bit here. Actually, okay, I'll show you with this. You can see this one here has a sander standoff installed, so the front and rear. Whereas this one here has got rear and front only, which is what you would want to use if you have a 30-30 stack and something tiny for your video. But if you need something bigger at the back, you can take off the standoffs, and then you can put your unit there, and you can fit at the front. If you prefer running rear standoff, you can run your equipment at the front as well. And all the provisions are there. Like I said, 30-30, 20-20 in the sander, 20-20 front and back. And I need to explain something actually about these little standoffs there, because if you look here, you've got a sunk nut right here on I guess the center plate, the main plate. Whereas curiously here, you have a standoff going through the entire length here. There's no sunk nut there, right? And that's because this sunk nut here is optional, right? They come pre-sunk, but they're not. They're optional basically. So if you wanted to run the standoff here, you'd have to pop that that sunk nut off, and then put your standoff there instead. It's always going through M3 here, M3 to the top. That bolt is perfectly aligned, and these standoffs they're profiled, and they've got a 6mm OD, so they just sit there nicely. Very much like you can see in this guy, although the standoff is slightly different here. It's an older prototype. So yeah, in terms of strength, we're adding these standoffs to the top plate, to the main plate, which is something that, as you can see here, for example, we don't have that. And likewise with the model before that, the Rooster, and then before that, the Chameleon, we never had center support or additional support for the top plate like this. And the reason that we find this really helps is that it adds stiffness on the roll axis. You see, frames like this never had much of a problem with the pitch axis, because you got the whole main plate there. It's quite long. You got the arms attached to it. You got the center plate, the top plate attached to it. You're not going to bend that easy the long way like that. But if you were to grab it the side way like this and trying to bend it, you have more leverage, you could say, to basically have flex going this way. And by adding a standoffs between here, the top plate, it sort of adds an additional layer to your roll axis stiffness, right? By all fairness, to the pitch axis as well, but more importantly to the roll axis, as far as what we can tell. So we recommend having at least 2 of these on at any given time the way you build this, and then you're going to get good performance out of this. So I think we covered strength. Let me check my notes here. Oh yeah, the cage is super smaller. Got the cam saver that moves a lot. Thicker arms. Oh yeah, the arms attachment. I will have to talk about this. In fact, I will show you how this all goes together here, and why we've got these holes going on in here. And yeah, I think that's it. So I'm just going to end the sequence now, and I'll be right back. All right, I'm back. Couple more things about, like I said, I've kind of broken down the provision as strength, modern provisions, weight, looks, ease of use, and then of course we're going to talk about noise as well. But in terms of provisions themselves, I also wanted to mention the stack's a little bit taller than previous versions. It's taller than the Marmot, the Badger. It's also taller than the original Chameleon. So yeah, We've added a little more room there because a lot of times we find that guys would like a little bit more room to, easily run their battery straps to, and, work on the build and whatnot. And then we've got this guy here that's included with every frame. There's only one installed on this, but there'll be 4. This little race wire. I'm not sure I should use the name race wire for this. Might be a trademark from another company who made these before us. And they're just basically little PCBs that you put on the arm here that solder to your motor, and then from there out to your ESC. And the reason why we wanted to have this on there is that with 4-in-1 ESCs, especially the 2020s, let's say someone ran it at the back here, that's how the person wanted to build it. The original motor wires that come with the motors may not be tall and long enough to reach, which would really not be pleasant from the perspective of putting together a build and having to cut wires and extend wires, add weight and welding and soldering. So basically that's what these are for. If your motor wires are long enough, you can run them right through and bypass this. You don't even need to use this. Although these actually work out to be lighter than 3 strands of wire for motors that size. So it does save on weight as well. So that was for a few last things I want to talk in terms of provisions. Cam 19 to 20 millimeter. That's one more thing actually. See, because of the way these cam savers are, you can easily bend them inwards or outward a little bit to have a slight variance in what cam you're using there, and that will fit easily from 19 to 20 millimeter width for a camera. And of course, if we talk about provisions, we've got the light grip on here. This is the sort of like that sticky stuff. Right, it sticks to your battery, but it's not the entire way through. That's why we call them light grip. The white part here is a foam, Eva foam, which is much lighter, and then the top part is that grippy stuff. So that's for the LiPo battery. So where else have I got on my list here? In terms of looks, we went with the classic orange of the original Chameleon. That's for looks. I think I should really talk about what we're looking at here next. So let's go ahead and do that. Just hang on a second. Alright, so what's all this shenanigans on the here? Well, what we've come up with, and I don't think we're the first guys, although maybe in the way we've done it, I'm not sure. But I noticed one frame was released recently, which was interesting to me because we came up with what we call a bra. I will show you the bra in a second, meaning it holds things in place. No offense now to any ladies listening, just call it a bra for for the purpose it's got. And I've seen another design that had something similar just recently. At that time, we'd already been sitting on this design now for quite some time. Anyways, yeah. So in terms of provisions here, it's very difficult. It's challenging to make a frame that has arms that attaches to the front. Arms that attach to the front, sort of like in an X configuration as you're seeing here, without interfering with your stack bolts. You want to put your flight controller in the center there, whether it's 2020 or 3030. And so there's been a lot of ways that different designs came about to try and circumvent that. Obviously, an easy way is to go more like an H design, having your arms attach a little bit further backward to give yourself room to have your stack bolts go through your center plate without interfering with the arms, right? And of course, there's a lot of designs out there that just you don't even take that for account. You'll have your you'll have your stack bolts for your flight controller go right through the same plate that holds the arm in, and the bottom plate through, right? So if you were to crash and an arm was to move, you got chances of causing damage to your flight controller. So that's one thing we didn't want, and it's something we had to do a lot of revisions to get to a point where the design is sound enough that even if you have slight discrepancies in tolerance when you manufacture the product, it still works. And why I wanted this that way is because we all know that if you on a lot of designs that will have a bolt like this going through the arm, right? If you crash it on a number of times and the arm is still holding up, that hole there is wearing out a little bit. It's being beaten up, and you may end up with a tiny bit of slop on that arm there. And that's one thing that I really did not want to have. That's another thing I really did not want to have any whatsoever complaint about arm slop. The arms can't move. If they move, the design is incorrect. We need to go back to the drawing board, try again, change something until we get it right. And it did take quite some time to do this. So what you're looking at here is basically your 2020 and 3030 provisions sitting right there, right? And once I open that up, you'll understand a little bit better where the bolts will sit to come through at the top here and attach your flight controller to, yeah? It's not 100% clear how that all works out yet. So I'm going, yeah, I guess I'm going to go right ahead and show you this. Let me give me a sec. I'm going to put top section on. There you go. Okay, so this is a prototype I have here now, and I'm just going to make sure everything's in place and then pop that top part. Here you go. And this is the part here we call the bra, right? This is your mounting bolt here, only one per arm. We don't need more. And now I do know that looking at this, some people will have concerns about these forks here breaking, but they don't. They just don't. And there's two reasons for this. The first one is that on this fork here, for example, you have support on the left and on the right, and it's actually wedged in. So this section of the fork cannot move right or left. It just can't. And likewise with this one, it's wedged in. It can't move either way. So that leaves this failing point here. And this is what would be called in an impact, right? If you were to hit the ground like this, where it would cause stress to your mounting bolt through your arm, you have to ask yourself, will the stress be distributed past this inward, or will the stress be caused here? And the answer is it'll happen here. If this arm breaks here, it'll break at the bolt. This is what you could consider a lever mechanism. This is your fulcrum here, and this is where all your pressure goes to, is at that bolt right there. That's your fulcrum, right? So you don't really need to worry about this here. What you do need to appreciate, though, and you will if you get your hands on this, is that by using a design like this, the arms simply can't move. They just don't. And one of the reasons for this, one of the main reasons for this, see, I mentioned already that it's all wedged in there, but also the center part here is thinner, right? It's thinner by design, so that once you tighten these, there's a screw here and there, which correspond with your sander standoff here, if you want to have one. Let me take this sander standoff here. We'd have a bolt going through here inside the sander standoff. Another one there. That's pressing. It's pressing the bra, the center section. Sorry, it's pressing down on towards the bra, but the bra is thinner than the arm, so it's applying pressure between the main plate and the arms, while applying very little pressure to the bra itself here, because the bra is thinner. So you got basically on this, what we're creating is a lot of friction on the entire surface of the arms, past the fulcrum, past the main bolt, and yeah, nothing budges. Like, nothing budges. We have had complaints with, what was it? I think it was, oh yeah, the rooster, of course. The rooster. We had complaints about the rooster with arms that became sloppy after a while, especially after some crashes. And we also had a problem, I remember now, about the bolts gave with it. Oh, goodness. That was a bit of a nightmare, but we did not go through these experiences as we go along year after year of doing this work without learning anything from that. And that's one of the things that I was really, really intent on achieving, is having arms meeting at the center that will not budge no matter what happens. If it budges, it breaks, is what it comes down to. It'll break right there at the fulcrum. If it budges, it'll break here. But again, they're thicker than arms that we've done before, and they're obviously cut what people would prefer in terms of the angle of cutting. So we got a lot more strength here and a lot more stiffness from a design like this. And the bonus point is that over here you're going to fit you're going to fit up to a button head bolt M3. You'll easily fit a cup head bolt in these slots here, but you'll also fit a button head bolt, and it'll sit against this main plate without any interference. Right, I'm talking about your stack bolts now, that what connects your flight controller to the main plate. Yeah, you can use cup head or button head at 20, 20, 30, 30, and it will be attached to this only, with no interference to the bottom plate or the arms. So in the event of a crash, your flight controller is not budging. And as you can see, it's quite easy to put that together and just pop that right back on there like this. Here it is. It's back the way it should be. With the bolts loose, of course. Now, let me grab a sip of a drink. I'll show you about removing an arm on this. Because as you've seen, we don't have, we only have one bolt through the arm. You just basically need to loosen the center bolt. I recommend giving a good loosen up, because as I mentioned, the center section is thinner, so you really want to get that thing loosened so that the carbon will be able to ease up. The pressure on the carbon will ease up on your arm, right? I should also mention that the way we've done this now is we didn't go so thin on the center section, being thinner than the arms, to the point where this plate here or the center plate starts bowing. It doesn't bow now. It's just, we've really got it right for this. You see, carbon fiber like this, the arms, center plates, all this stuff that you see on the market these days, you get your parts from a sheet of carbon fiber, and there's always going to be discrepancies in the thickness of these carbon fiber sheets. That's actually the hardest tolerance to control when you design something with carbon fiber sheets, is that while your machines can be very, very precise at cutting the carbon fiber and getting all these cuts perfectly and everything lining up perfectly, the thickness of the plate itself is a whole nother story, right? So in order to remedy this and not have that problem, we're actually milling these center section on an extra axis, right, which is just something set up to bring it down to the exact thickness that we need to milling precision, right? So as such, we're guaranteed now that it's just going to squeeze on there like mad. So I removed these, I loosened these two here. Let me just take this one out completely. That's the one going through the arm. I can get it out. Hang on. This has never been crashed. Tolerances are tight, obviously. And now I can just simply pull that arm out. Right? I actually felt this is loose. Yeah, nice and loose. And that's it. One bolt to remove only. You loosen two. Time to put that back in. Put a new arm in, just like this. Put your bolt. Tighten that up. And when I say tighten that up now, another thing that we changed with this now, yeah, is in previous detachable arm models that we use these bolts here, which use a finer, smaller X driver. This is 2.5, I believe, for these bolts here. But that's the actual arm attachments, all these bolts here. This is 3.0, right? So you don't need to torque that hard on this now. Which one did I remove? Is this one? So I can just, like 3 fingers literally is enough. 3 fingers. Go a little bit harder if you want, but tighten the center screw. Again, don't need to torque it that much at all. And then that's it. This will not move now. It will not move even if your hole here, you could literally drill that hole in the arm that this bolt secures it to bigger, but by the time you tighten all this together, your arm will not move now. I personally guarantee that. This is the best arm attachment that we've ever come up with. It's bloody fantastic. One last point though, that this one is, what I'm about to show you is optional. It's not something that you have to use. You see over here we've got a very, very thin layer of foam that basically your arms, as I showed you here before, let me strut this over, that will push down on this section here. Now this is not needed. It is not needed now. We find that it's nice, but it is not needed. Basically, whether you put this on or not, your arms will be clamped down very, very strongly. And this is actually, I'm not kidding you now. Well, for guys who are into putting tape on their arms or grease, like some people have mentioned, or other things that people may use that they find helps them to get the better tune. This is thinner than a layer of paper now. That's how thin this thing is. It looks a bit thicker than this when you put it on, but by the time you tighten your bolts on it, that thing gets squished down so hard. Yeah, there's basically nothing left of it. It's thinner than a piece of paper. Oh, and to be clear too, if you look around here, you see a little bit of what looks like glue here. And this is because this foam here is one side sticky. You see what happens with this is that this foam is so thin that we can't die cut it. So one way that we were able to die cut it is to make it one side sticky. And then from there we're able to die cut at that thickness there. But once again now, to make sure everyone is clear about this thing is not needed. Something you can play with, that's it, nothing more. Of course we got the white, that's in terms of looks here. We got the white foam here, and we'll have the white battery straps with it too this time. Be kind of nice. Get 2 of these with each frame or build you purchase. So what else do I have to talk about this? Oh yeah, I have 1 or 2 things more I'd like to talk to you about. Hold up, I'll be ready. All right, so just a few last notes here before we wrap this up. I forgot to mention this here at the front, which I think is important to mention. I've mentioned earlier in the video that this standoff here, right, is optional. It can be popped out of there. From there, you can use a longer screw, which is included in the kit. Grab this to mount a standoff at the front. All right. Now let's say that you don't want to run that standoff at the front, right? Let's say that you put something at the front here, like, you know what, I don't really want this one. I'd rather to have my standoffs at the back. No problem. Also included will come a sunk nut for this and this, right? You will need to pop it out to put your standoff there. But the difference with this sunk nut is instead of facing up like this, it'll be on the bottom here, right? Even with the top of the plate here, so that you're able to use this from there without having a standoff here, right? You will be able to use these 2 holes there. Those 2 provisions, right, that I forgot to mention, to attach a GoPro mount or whatever you want at the front here, right? That's the idea. So much like here, right? This standoff is optional. A standoff that you're not seeing here is also optional. Now we'll show you. That's the wrong driver. Hang on a second here. That's better. Take that bolt out here. Now remember, this bolt could potentially be used to secure a GoPro mount here, which a lot of the GoPro mounts that are out there now, I'll talk about them in a bit, will use this provision here, and this one here, I believe. This provision, this standoff here, and then these two provisions at the back. Now let's look at it closely. Can you see this hole is huge now for M3 bolt? I mean, my finger will hide it now, but if I try to put it, this M3 bolt, I'm trying to see if you can see the size. M3 bolt is tiny, this hole is big. That's because this hole is meant for a sunk nut, like this, right? You can put a sunk nut like this in this hole here. And that's, again, to have that additional provision to mount your HD cam at the front, if you wish, or I should say if you do not wish to run this standoff here. Okay, so I think I've just about got through all my notes here. Just a few more things. When you finish assembling this, it does come with an assembly manual. Make sure you get all that right and get all the bolt length right and whatnot. But you will have a whole lot of bolts left, and so don't panic. There's dogs barking now. Hopefully they don't start. Be nice, dogs. Be nice. Yeah, you'll have extra sunk nuts, extra bolt of every size that you're using there. You'll have extra. You'll also have longer bolts to go through here, where you two want to use a standoff at the center here. And maybe you'll be wondering, well, what am I supposed to use with these bolts? What am I supposed to do? You will have extra bolts, and you will have potentially extra standoffs too, if you only use 2. You don't want 4 installed, depending on how you build it. So yeah, don't panic about the extra bolts. You're going to have extra bolts, M2 for the cam. You're going to have M3 bolts of every length on this frame now. You will have at least 1 spare, and it adds up. You end up with a nice little pile of bolts there. You don't need to worry if you screwed up or not. You didn't. The frame comes with it. Put them somewhere. They may come in handy. And another thing I need to say about this is so cool. We partnered up with HQ Props. Big thank you to Tong, the owner of HQ Props. Every frame sold until stock lasts will come with 2 free sets of props, and they're the more recent tri blades from HQ Props. They're super nice, very popular at the moment, and very appropriate for this frame, for a freestyle frame like this. So yes, a big thank you to HQ Props. Everyone will get 2, and I mentioned this also not only as a thank you to Zong, but also as when we're talking about price point here. You get 2 free sets of props with this. Helps a little bit, makes it a little bit cheaper, a little bit more affordable. You don't need to go and buy 2 sets of props somewhere to put your model together. You have a backup if you crash. You need extra props. And to finish this off, as always, I want to say a massive thank you to Jason. Jason's worked with me for a number of years now. Yeah, he's been just such a great asset to Armattan. And also a big thank you to Brain Treaty, who this time worked with us to put together all kinds of prints for this, for the arms, ends, GoPro mounts, camera mounts, you name it. Brain Treaty does all this stuff. And then, so all of this will be available in their store and on launching day. And there's also, thanks to Brian, Brain Treaty as well, there's also a number of designs available for free to download on Thingiverse, which will be linked in the product description on our website, where you can navigate to and then download the STL files you need to print your own parts, which I think is super neat for guys out there who have the ability to print their own parts. Lastly, a big thank you to Chris Wynn for working with Brian on some of the developments there that went on with some of the printed parts, and also with other aspects of testing, feedback. Yeah, some of the changes actually in this came from sponsored pilots. Dennis Meadlick also helped. I'm not sure how to pronounce his last name. I'm sorry, Dennis. Yeah, and of course, as always, a big thank you to the whole Armattan team. And lastly, as always, a big thank you to all of you out there watching this, all the people who've supported us over the years. We appreciate it more than you know, and I hope you like this guy here, the Armattan Beaver. All right, cheers. Thank you.